All right, I need to figure out what x is. Well, the good thing is I have a point outside the circle, right? We have an intersection outside the circle, which means we're going to use subtraction. It is big arc minus small arc divided by 2 equals 58. Here's the problem. This is length x. I don't have a clue what this length is. What should I write that arc as? Yeah. 360 minus x. Perfect. So we'd have 360 minus x. So then we could say, well, the angle, which is 58 degrees, is going to equal 1/2 our big arc, which is 360 minus x, minus the small arc, which is x as well. Well, I'm going to multiply it. Yeah, let's just multiply everything by 2. It'll be fine. If I multiply everything by 2, I'm going to have 116 degrees equals 360 minus 2x. Then we're going to have negative 244 equals a negative 2x, so x will just equal 122 degrees. And that was A, I believe? Yeah, A. Correct answer A, 122 degrees. Questions on the bell work? All right, questions on the homework. Leanne? Can you be a little more specific? 5, 6, 9, and 10? Okay, let's go with the easy one first. Ladies, shh. It should just be me talking. All right, I already forgot because people were talking. Okay, 9. Let's do 9 first. This is a tangent line. A tangent line that has a line going through the center of the circle is automatically going to be 90 degrees. So this is 90 degrees. This is also 90 degrees. That will get you 9 as being 90 degrees. It'll also get you 10. Because did you say you were missing 8 or you had 8?
I have 8.
You have 8, and that means you have 1, right? So we can just, it's a triangle, and then we subtract that away. And then you're talking 4 or 5, maybe? Did you say 5 and 6? All right, let's look at 5. Do you have 8?
Yeah.
Okay. If you look at 8, we have a vertical angle on the other side. Right, so we'd have this one, so this would be a triangle if you have 4. So then we have 5, right? Do you see that triangle?
Yeah.
Oh, okay. So that gets you 5. The other way we could have done 5. Let's say I didn't see that triangle. If I look at 5 and I highlight it for you real quick, let's make this a little bigger. I'm going to highlight something to you. It's this. 5 is an angle of 2 chords meeting at a point inside the circle. You know this arc. This arc is DE. They said that DE is 20. So I know that arc is 20 degrees. I also know that this arc here would be 90 degrees because this was 90 in itself. So that would be 90 degrees. It actually says that B is 90 degrees too. So we could have just done 90 plus 20 divided by 2 would also give you 5. Another way to do it. A lot of these have multiple ways to get to them. Okay? And then you're talking about 6?
Yeah.
All right. If you know 5, you actually know 6 because it's a straight line. It's just 180 minus 5 will get you 6. If you look up here, another way you could have done it is you could have got the measure of arc CD, found this big measure, and that actually would have got you 6 as well. Okay, were those, did I do all of them?
Yeah.
Do they all make sense though? Okay. Hamza.
On that one, can you explain again how you got 5 using like the 2 arcs of 90 and 20?
It's an intersecting lines. And we said yesterday if we have intersecting lines on the inside of the circle, it'll be arc plus arc divided by 2 will equal that angle. Yep. Other questions on any one of them? Yeah. You sure? Okay. Good.
Can you do number 20?
Yeah. 20, no. Cool. Let's go to someone else. Yes. 20? Okay. All right, 20 is one that says that measure of arc xy equals t, and then measure of x, z, y equals something, and angle p equals something in terms of t. Is that the correct one? Okay. So the first thing I would do is, what's labeled for us? Oh, x, y equals t. So I'd label that as t. It's almost like the bell work. It's almost exactly like the bell work in the fact that, well, it's exactly bell work question. We have to label this as t, which makes this big arc 360 minus t. So that's going to mean half the measure, or this angle is going to equal half our big arc minus our small arc, which is kind of what we did in bell work, right? And then we'd come up with measure of angle P actually equals 180 minus T. And that's as far as we can go. We're not going to get an actual number. We're just going to end up with 180 minus T. But it's asked differently, but it's very similar to our bell work question. If you know one little element of something, at least try plugging in the equation. Does that make sense?
Yeah, I guess I was just confused because I just put everything over to the side because I'm the half just look different.
Oh, okay. The half just look different. Yeah, okay. Yeah, I'm sorry.
Can go over 22.
22 is a secant and a tangent intersect at 42 degrees. So we skip 23, I guess. All right, so I have a tangent and a secant intersecting at 42 degrees. The two arcs of the circle intercepted by a secant and a tangent have the measure of 7:3 ratio. Well, the one furthest away has to be our bigger arc. So since it's a ratio, I don't know that it's 7 and I don't know it's 3, but I know it's 7 times some number, and this would be 3 times some number to keep that ratio. All right, so then we just have to do big minus small divided by 2, and that'll get you your x value. You can work from there.
Oh, okay. So it's looking for that arc, not having an x on it, right?
Right, yes. Yep. Other questions? Going once? Place sold. All right, let's talk about today. Today isn't that hard. We're once again going to talk about lines and chords that intersect inside a circle and chords and lines that intersect outside of the circle. So the first one we're going to look at is when they intersect inside the circle. Yesterday we talked about the angles. Yesterday we were talking about the angles. We said basically this angle would be the two arcs added and divided by 2. Today we're not talking about angles, we're actually talking about lengths. We're talking about the lengths of AC and ED. That's what this little theorem says. We'll get to it as the PowerPoint theorem. But it is, if two chords intersect in a circle, then the products of their lengths of the segments are equal. So if we look at right here, we don't know that these two lengths are equal or anything. But what we do know is if I take a segment times a segment, it's going to equal this segment times this segment. So in other words, AB times BC is going to equal DB times D or BE. Segment times segment equals segment times segment. It's all the same. Two lines intersect inside a circle. You just do segment times segment on the same line equals the segment times segment of the other line. So as an example, let's do example 1. You're going to ask yourself, are those two chords intersecting inside a circle? Yes, that point is inside the circle. Am I looking for a vertex or length? I'm looking for lengths. So that means we're going to use this one. Mine is super blurry. I should have made these a little bigger. So I'm going to write these values right next to it. So this one should be 36. This one was 54. This is K. And this one is 48. All right, lengths inside a circle are going to be segment times segment. So we'd have 54 times 48. is going to equal segment times segment, so that would be k times 36. Well, 54 times 48 is going to equal 2,592, and we have 36k. All we have to do is divide both sides by 36, and we're coming up with k equals 70. Our next one is the same problem. We have intersecting lines inside a circle, so it's going to be segment times segment equals segment times segment. In this case, you have x times 3x equals 6 times 8. So we are going to have x times 3x is going to equal 6 times 8. That's going to give me 3x times x is 3x squared, is going to equal 48. Which we're going to have x squared equals 16. We'll take the square root of both sides, and we'll have x equals positive or negative 4, but we only want the positive answer, so the x is going to be 4. Questions on that? That's it. That's what happens when two lines intersect, and I'm looking for lengths. All right, the next thing we're going to talk about is what happens when lines meet outside of the circle. As indicated here, 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 and here. Let's get some terminology straight real quick. I'm going to talk about things as being whole and external. When I say whole, I'm talking about the entire line. So that is our whole secant segment. But the big word there is whole. The other word I'm going to use is external. When I talk about external, I'm talking about that segment that's still outside of the circle. Just the part that's outside the circle. This is going to be our external segment. So we're going to read this, and then we'll go over what it kind of means. It says, if two secants intersect in the exterior of a circle, then the product of their measures of one secant segment and its external secant segment is equal to the product of the measure of the other secant and its external secant. What that is saying is whole times external equals whole times external. So if we look at this, it says that AC times AB. Well, let's look at AC. AC is the whole length. So if I write down below it, AC is actually your whole length. Times AB is your external length. You do whole, and then you reduce it down to the external, and you multiply those two things together. So it's going to be whole times external is going to equal AE is that whole length too, times external. I'm going to really stress that you understand that that's whole times external. Because here's the problem. People generally do these pretty well, because it's just this times this equals this times this. The problem comes in when I bring this up. A lot of people want to do AD times DE equals AB times BC. It doesn't work the same as internal. You can't do segment times segment. You have to do the whole length times that external part equals the whole length times the other external part. Don't fall into that camp of people that forget. You have to remember, you need to have this whole length and you need to know this external to do this. Whole times your external. I'll say it a billion times because people are going to still make that mistake. So if we go down here, example 3, the mistake I'll see on the test is people going 6 times x equals 4 times 8. That will not work. What I kind of want you to picture is as soon as you see it intersecting on the outside and looking for lengths, what I want you to do is picture in your head what the whole length is. So that whole length is x plus 6. This whole length is going to be 12. Now if I'm thinking whole times external, Now I can picture it as being x plus 6 is the whole. That is that whole length. And it'll be times our external length. I'm going to cross that out. Our external length is 6. That is our external. And that's going to equal the whole length of the other one, which was 12, times the external, which is 4. All right, now we have to distribute that 6 to both that x and that 6, which will give me 6x plus 36 is going to equal 48. Subtract 36 on both sides, and you should end up with 6x equals 12. Divide both sides by 6, and you come up with x equals 2. Honestly, those two things are the only things we're learning today. Those are the only two items we're learning today. It's going to look a little different on the other side. We're going to talk about a tangent, but it really is the same exact property. You just need to know. If it's inside, segment times segment. If it's outside, it is whole times external. Remember that when we get to this next part. This next part is going to be talking about secants and tangent lines. It is still that exact same property. It is still whole times external equals whole times external. However, what's the whole length of JK? Not like how high he is. I'm talking about get it? You didn't get it. No. All right. What's the whole length of JK? Yeah. It's JK. What's the external of JK? It's the same thing. So if you read this, it says that if you have a tangent and a secant, it's going to be JK squared. It's going to be your tangent segment squared. It's going to equal your whole times your segment. But it's still whole times external. So in this case, we would have JK times JK, but it's still whole times external. And that's going to equal JM times JL, which is still whole times external. Let's just leave it E. So it's always going to be whole times external. Except in this case, JK times JK is just JK squared. So you can just square that number as well. All right, so example 4 says solve for x. Well, look at your tangent line. The whole length of that line is 6. The external portion of that is also 6. That's going to equal the whole length of the other one, which is 9, times the exterior, which is x. Well, that's 6 times 6, which is 36, equals 9x. Divide both sides by 9, and you come up with x equals 4. Hamza.
What if that tangent like extended like beyond, just like touching one side? You know what I mean? It's like a whole line.
Like going there?
Yeah.
Well,
Would the whole be?
no. The whole will still be this segment.
Okay.
It's what affects the circle, basically. So this length goes to the circle here. Past that, it's not working with the circle anymore. So a tangent line will always be this number squared. All right? Anything longer, that's not going to help you. It has to be this length. All right. Both of these fall into what's called the power of a point theorem. Power of a point theorem. Whether that point is inside the circle or outside the circle. So the first one's inside the circle. If it's inside the circle, you're going to do segment times segment. So AP times PB is going to equal CP times PD. If it's on the outside, you have to do your whole times your segment. So in this case, we would have R times S equals T times U. And finally, if you have a tangent, well, since that tangent line is the whole and the external at the same time, we can just go, okay, it's going to be R times S equals T squared. Or you can go U squared, whatever. It is the fact that this whole length is the same thing as external. So whole times external is just T times T, which is T squared.
What is
Sam, do you have a question or anything?
Wait, so is it like adding or like it's multiplying, right? With like all three of them, right?
All three of them? You're not multiplying with all three of
But
them.
like it's like
Can I go back to, I think I know what you're talking about. Can we go back to, I guess, this one? On this one, we would do 8 plus 4 would give me 12. So that part you add. You add to get your full length. Then you multiply.
Yeah.
Then it's whole times 4. So that's where we came over to 12 times 4. So you add the lengths to get your full length, but then you multiply once you have that whole length. That's why I think it's a good idea. As soon as you see the external, you find that whole length by adding. Then you don't have to worry about having addition inside.
Yeah.
Yeah, the only thing you have to worry about is because we have x plus 6, so it has to stay x plus 6. Is that good?
Yeah.
Hands up.
What is the C, C, and T equal to for?
It is saying, if you look at that as being whole times external. So if I said t is that whole length, then u would be that external, but it's the same length. It's like how I put r compared to s. R was my whole, S is my segment. T is your whole, U is your external. They're both the exact same. So it'd be T squared or U squared. Whatever length that is, you square it.
Okay. And then what about the C?
C is D is kind of like, so see how this was kind of two segments? We had this one and this one.
Yeah.
We're saying it's tangent, it's the exact same length.
Oh, okay.
C would equal D if you needed 2 points.
Mhm.
If I needed 2 points in a circle, but it only can hit in one place, so you can't name 2 letters for it.
Okay.
If it's confusing at all, Hamza, just do this.
Yeah. Okay.
Yeah, if that lettering, it was just to compare a whole to a segment. But if it's confusing at all, just go, okay, it's C and T.
Okay.
Other questions? Those are both really good questions. All right, if there's no other questions for me, then the rest of the time is for you to work. Make sure you have your homework accessible. I'm going to walk around and I'm going to check your homework. Quick reminder, test is on Monday. You have a review day tomorrow and the next day. You do, if you really want to, you have the option to take the test on Friday if you really want to. Just make sure you come before and tell me you're taking it on Friday so I can have it printed out and have time for you. All right.